NASA's live stream went dark seconds later. The footage vanished. What did they see? According to Brian Cox, this changes everything we thought we knew about space. A new object, Oumuamua, entered our solar system, stopped, changed direction, and sent a signal made of prime numbers straight to Earth. Then the Voyager probe answered back with a message it was never built to send. This isn't science fiction. It's unfolding now, and Cox is warning that this may not be contact, but judgment. If you're watching this, you're already part of the story. And trust me, you need to see what happens next. NASA's abrupt cutoff started like any other quiet data stream. A routine sky survey from a deep space telescope positioned over the Pacific Ocean. Scientists were monitoring the feed, scanning the stars like they've done 1,000 times before. But then something changed. The camera picked up an object, unfamiliar, fast-moving, and close. Before anyone could figure out what they were seeing, NASA shut the live stream down. No warning, no explanation, just static. Within minutes, the raw footage vanished. Not archived, deleted. Scientists scrambled to retrieve logs and backup files, but nothing remained. The system registered what appeared to be a global data purge, a rare move, even for sensitive observations. That's when physicist Brian Cox went public. Appearing in an interview just hours later, he said, "What we're witnessing may force us to rewrite everything we thought we knew about deep space." It wasn't just dramatic, it was a warning. The object was later named Oumuamua, a nod to the original interstellar visitor from 2017. But this one wasn't just passing through. It was coming closer. Unlike the first Oumuamua, which flew through the solar system and disappeared, Oumuamua slowed down, changed direction, and then stopped. That's when people started to realize this wasn't a comet. This wasn't a rock. Whatever it was controlled. The strange part isn't just that the feed was cut. It's how quickly and completely NASA locked down every trace of what happened. Backup servers were cleared. Data channels went silent. Even publicly available observatory logs stopped updating. It wasn't just a blackout. It was a blackout with urgency, as if someone somewhere didn't want this object being seen any further. And when one of the world's most trusted physicists comes forward and says, "This might change everything," you listen. But what exactly made Oumuamua so different? What did scientists see in those few seconds before the feed was cut that pushed NASA to go dark? Let's look at what makes this object so strange and why its movements defy everything we understand about how things move in space, Oumuamua's impossible behavior. From the moment it was spotted, Oumuamua behaved in ways no natural object should. At first, it looked a lot like the original Oumuamua, oddly shaped, long and thin, almost like a spinning piece of space debris. But then came the first red flag. It changed direction on its own. Not because of gravity or impact, but because something made it move. As Brian Cox explained, we are witnessing non-ballistic motion. What does that mean? In space, objects follow predictable paths, unless something pushes them. A rock can't suddenly curve toward Earth or slow itself down. But that's exactly what Oumuamua did. It slowed its approach, altered its heading, and came to what looked like a complete stop. There were no visible engines, no thrusters, no tail like a comet. Just a quiet, deliberate pause in the blackness of space. That's not a rock. That's something else. NASA's Deep Space Network registered tiny micro-vibrations coming from the object. The patterns weren't random. They were consistent with something operating internally, like guidance systems, maybe even stabilization mechanisms. If this was a spacecraft, it was either self-adjusting or being remotely steered. Alongside those vibrations, researchers noted thermal fluctuations. These weren't caused by the sun. The heat signatures seemed to pulse, almost like the object was cooling itself, shielding, regulating, or even cloaking. All this was happening silently, with no communication and no obvious energy source. That's what made it so alarming. A comet might speed up as it nears the sun, shedding gas and dust. But this thing, it was smooth, clean, and purposeful. Cox wasn't being dramatic when he said it breaks the rules of physics. It does. Or maybe it doesn't. Maybe it just follows a set of rules we haven't discovered yet. As if all that wasn't enough, something else happened right before NASA pulled the plug. A pattern of pulses. Not random noise, but carefully timed prime numbers. Directed not at space, but at Earth. The pulse, before blackout. Just before the live stream went black, the telescope picked up a series of light pulses coming directly from Oumuamua. At first, they seemed like flickers, nothing unusual for space objects reflecting sunlight. But within seconds, a pattern formed. Not chaotic, not atmospheric, structured, deliberate, mathematical. These were prime number intervals. Maybe 1, 3, 5, 7 cent, as light beams aimed straight at Earth's upper atmosphere. To most, that might not mean much. But in the world of astrophysics and alien communication theory, prime numbers are a key wake-up signal. They're universal. No matter what language you speak, if you understand math, you understand primes. Carl Sagan once said that if intelligent life ever tried to communicate, they'll send primes. It's the one language we all speak. And here they were, flickering from the edge of space, just before NASA shut it all down. The pulses were detected not just by the main telescope, but by other independent systems, including magnetometers and observatories in Chile and South Africa. They all picked up the same thing, a beam targeted at Earth's magnetosphere. It wasn't strong enough to do damage, but it was powerful enough to be felt. This wasn't energy for destruction. It was information, a kind of coded hello. And then, silence. The moment. The pulse reached Earth. The moment the pulse reached Earth, the feed cut off completely. Not a gradual drop, a full system crash. And right after that, the footage vanished. NASA's logs were emptied. Backup servers cleared. Public access to the event was locked behind security credentials, as one anonymous researcher later said. It's not what we saw that scared us. It's what we felt watching it. It felt like a test. But this wasn't the first time something like this happened. In fact, if Oumuamua seemed oddly familiar, it's because we've seen something like it before. The 2017 Mystery Reborn. Back in October 2017, astronomers at the Haleakala Observatory in Hawaii spotted something odd moving through our solar system. It was named Oumuamua, which means a messenger from afar, arriving first in Hawaiian. Unlike anything scientists had seen before, this object wasn't from our solar system. It came in fast, tumbled oddly, and reflected light in strange ways. For a moment, the world looked up. Oumuamua wasn't round like a planet, or fuzzy like a comet. It was long and narrow, like a giant cigar drifting through space. As it passed, astronomers noticed something even stranger. It accelerated, not because of gravity, not from pushing off something. It just sped up. That's when theories started, flying. Most scientists tried to explain it as a weird, icy rock behaving strangely. But not everyone bought that. Harvard astrophysicist Avi Loeb publicly said what many were thinking. He suggested, Oumuamua might not be natural at all. In his words, it could be a light sail, a thin technological object using radiation from the sun to move. It wasn't a joke. He backed it up with real data and serious math. But before anything more could be studied, Oumuamua was gone. It zoomed out of our solar system, out of reach. Now, fast forward to Neo Oumuamua. It has the same weird shape, the same strange rotation. But this time, it didn't leave. It stopped. It watched. It reacted. Unlike its predecessor, this one gave us just enough time to see its true nature, and maybe even respond. That's why scientists are so rattled. Oumuamua left us with a question. Neo Oumuamua? It feels more like an answer. But maybe it's not an answer after all. Maybe it's a test.